Hello all. Today on the bench we have an ICOM IC-746 HF amateur transceiver. This unit was sent in by our viewer and friend John. If y'all remember John, he is the one that built and donated the Dell computer to us. And he also sent in this GeForce 8400 GS video card, and I have that installed in the computer, and it is working like a charm. It really helped with the microscope camera. So thank you, John, for sending that in. So John had his radio on, and he was doing some things, and basically noticed that it had shut down. He pulled it open and started testing. He found that R44 on the PA board was running extremely hot. So he got in with some troubleshooting and traced it down and found a SMD component on the main board that was charred. So we're going to get in here and take a look at this and see if we can find out what caused this component to go nuclear on them. So let's get it cracked open and go ahead and get a look at it. So I removed the top and bottom cover, and there's also a shield in here that you'll need to remove all the screws out to get this off. You see our speaker assembly there. Let me set this to the side. And I'll reposition the camera so we can get a better shot. So John pretty much did his homework when he was troubleshooting this thing, and he took a few pictures and emailed them to me and was asking questions and this and that. Then he decided to go ahead and send the radio in. But located right here on the PA board, you can see this resistor here. This is R44. And he had found that it was running very hot. So what he did was traced it out. And I'm going to go ahead and tell you the original service manual that you find online for this radio is horrible. I mean, the schematic is good, but the board layouts and stuff, you know, it shows both sides of the board in one view. So it makes it very difficult to troubleshoot and follow. Now I hear that the original service manual is better, but still there are some difficulties even in the original service manual. So John had traced out this resistor, and he found that it came through this ribbon cable. So we'll turn the radio over and have a look at the bottom. So you see, here's the ribbon cable here, and John traced on through and found a small component right here that's beside this capacitor and crystal that has been charred. And it's that little component right there. He could not find it on the schematic and the board layout. It was just unreadable. You could not figure out what it was. So I went over to a website and made a post on the website and showed pictures of it, and at first I did not get no reply back. But in the meantime, I had emailed Mike over at Mike's Radio Repair and showed him the same thing. Now Mike is very good at troubleshooting circuits, so he had come back and verified what he thought it was. So let's have a look at the board layout schematics. So here we are on the board layout, and you can pretty much see how I was talking about it. It shows both sides of the board at one time, pink side being one side, and then there's a gray trace from the other side, and then when they laying on top of each other. You see it's dark. If we look right here in this area, right up in here, we can see this small transistor. Now, let me go ahead and expand this over a little bigger, and the bigger it gets, the worse it's going to look. But we can see the component basically right here, and we can see it's a a 3-pin package. So to start with, I didn't know if this was a dual diode pack or a transistor or just what it is. Well, it happens to be a SOT 416 package, so it's very small. And at this moment, I know that we have one pin that is grounded. We have one pin that comes up and sneaks its way up here to this microcontroller. It's right over here on this side. Right here, and I believe it was pin, it's either 91 or 41. I have to go back and look at it on the schematic. So we were able to verify that this is Q1705, and this is a DTC 114 EETL, and it's an NPN transistor that has 2 bias resistors installed in the package. And by looking at this, it appears to have been in the squelch circuit. Now, why this thing went nuclear is a mystery. So I think what we're going to do is go ahead and get this transistor removed, and we're going to check between here and the microcontroller and see if we still have continuity. And we're going to check from these other 2 pins to ground just to see if anything is shorted. Now we know we're going to get a connection here to ground, because this is the ground trace for this one pin. But the biggest thing at the moment is go ahead and get this burnt component off the board without damaging anything, and get it cleaned up and see how it looks. So as you can see just how bad this component is burnt up, and I'm really hoping that the circuit traces below it are not that damaged. Now, one thing I do need to do is go ahead and purchase a proper LED light for my microscope. The homemade one that I'm using is a fluorescent tube, and the lighting is not that great on it. I mean, it's pretty bright. In fact, it's too bright, and I'm having to put tape over the bottom of it just to shade it, tone it down just a bit. But as you see, it makes everything look a little bit yellow. But I think I'm going to go ahead and go online and see if I can find a good adjustable LED light ring for this microscope. Anyway, let's see if we can wait on the solder station to heat up. And I'm going to go ahead and I'm not going to use hot air to remove this. I'm going to just go ahead and use a soldering iron. If you know anything about a SOT 416 package, it's very, very small to start with, so I don't want to heat the board up no more than I have to with hot air. So we're just going to put some flux on it and take the soldering tool and see if we can't just basically wipe the component right off the board. I'm going to just leave my standard chisel tip on there so we can cover as much of it as we can, and just put a good solder ball right on it and see if can't we just get that component right off. and it is off. Had part of one of the old pins still on there. And you see one of the traces lifted right off. Now most of the time what I would do is get down there with my fiber brush and clean that area up real good. Unfortunately, my fiber brush is all but wore out, and I don't want to risk damaging any more traces than what's already damaged. You can see this bottom trace. Since it's the smallest, it took all the heat from this, and that's what delaminated it from the board. So when we got the old transistor off, it just lifted right up. So we'll have to glue that back in place. You know, it's still attached, but we'll have to get it, and this end is folded under right here, so we'll have to get that unfolded, laid back out, and see how good it looks. Might have to run another piece of trace over top of it. Let me go ahead and get all this cleaned up. Well, that don't look too bad. Got most of the old burnt carbon up off the board. I'll see if I can get that other trace back in place. Yeah, I can see the fold in it right there. Well, by looking at it, I think our solder trace is, our circuit trace is going to be okay. It doesn't look too bad at all. We just have to get it, you know, completely back in position, and bond it back down to the board with some CW20, and that should take care of that problem. What we are going to have to do is come in here and ohm out those connections and see if you know, this trace or the whoa, too far. Or if this trace here, one of those two could be shorted to ground. Now you see this pad is completely burned off and gone, so we'll just have to jump over from it. Shouldn't be too much of a problem. Okay, while we at it, let's go ahead and see, can we check those other pins for shorts to ground. Well, that's interesting, no shorts to ground on two of the leads. So it really makes you wonder why this thing went thermal like it did. Let's go ahead and pull up the schematic and take a look at it. So here is the transistor in question right here on the schematic, Q1705. And as you see, there's not a whole lot going on there. It's just comes right over here, goes to the squelch on the collector, and the emitter is grounded. And we can follow SOSS right on down. We have to go to the other page, and we'll follow it right on up. It's going to take off and come right here to pin 41 of the CPU. It's pin 41 right here. So, you know, it really has to make me wonder if something happened here at the microprocessor, or something on the other end. If the voltage had went up too high and caused this issue. It's just you know, it's hard to say right now at the moment. I guess we'll probably need to follow out this end here and see if we can figure out just what is going on that could have caused this transistor to burn up. Right now, you know, it's still a mystery. So I'm thinking what I'm going to do now is push the microscope back out of the way, and we'll go ahead and power the radio and check voltages on that circuit and see just what's going on. I got our radio connected to Harrison Laboratories power supply. I got it sitting on about 13.8 volts. I'm going to power the radio up and see what happens, see how much current it's drawing. Alright, the radio powered. I heard the relay kick in. I hear a slight hum in the power supply up there, but there's no indication on the front of the radio that it's on. But checking with a voltmeter, I can see that the radio is on, and it is drawing about 2 amps, as you can see on the meter. So it's not drawing a whole lot of current, but it is drawing a little bit of current. And just feeling here, I can feel some heat coming up from that resistor. Yeah, she's pretty warm. So it looks like we need to focus our attention to R44 on the PA board and see what that's going to and what's causing that resistor to heat up so much. But before we do that, let's take a look at the voltages down here under the bottom. So it looks like the collector is got about 8 volts on it, and the base has about 4 volts applied to it. Now we know that the base on this transistor is actually an input, and the collector is an output. So the 2 voltages there being, 4 volts and 8 volts do concern me, and that's probably why it exploded like it did and burnt the transistor up. So we're going to go ahead and trace back to R44 and see if we can figure out what's causing it to run so hot. I'm pretty sure there's another component that is either shorted or something's gone wrong that has caused that to get as hard as it is. Okay, so here we see R44 on the schematic on the PA board, and directly under that is C85, which is a 100 microfarad cap. We got 14 volts going into one side of the resistor. It comes down and it goes to IC2, which is a TA7805. But then we have to question this capacitor, which is C85. And if we go to the board layout, which is on page 88, we'll see R44 here. Right there is R44, and this again as well is talking about the shading of this manual. And you see here we have a dark area, which is the same as this. And then we got a pink area here. So it looks like to me this is probably C85 right here. That's what it looks like to me. So we need to check this cap and see if this cap is shorting, and that could be causing this resistor to heat up, because okay, I have the main board out of the radio, and it's, very simple, but like 7 screws, and just disconnect the ribbon cables and the coax cables from it and have it out. So now we need to go ahead and replace Q1705. Now if I just had the part right here in my hand, I could go ahead and do it. And there we are, with the magic of YouTube. So I ordered 10 of these. They went for like $2 for 10 of them. You see them in this little strip right here. And again, these are stock 416 packages. So I'm going to go ahead and get one of these out, and you can see just how tiny it is. And there's the part. Yes, you can see just how little it is. Those are tiny little things. So we'll have to do this under the magnifying glass, or the microscope. That's about the only way we can even see the thing. I went ahead and placed the part up there on the circuit board right here, and I'm sorry about this lighting. It's terrible on this thing, but looks like the part is going to, it's going to place just fine with no problems at all. Block some of the light, you can see it a little better. The pads line up, the collector lines up with the trace that was lifted up with no problem. So we can go ahead and get this soldered in place and see how that goes. Alright, now that we got our components soldered back in, I'll go ahead and reinstall the main board. And I'm sorry about all the noise in the background today. I have a fan running and my air conditioner wants to act a little strange today for some reason. Actually started yesterday afternoon. It started going into defrost mode. And I got out there and messed with it a little bit, and it started back working, but I can tell something still ain't right. And it's done it before, and for some strange reason every time it does it, it ends up fixing itself. So I'm not sure just what's going on with it yet, but I'm going to have to get down to the bottom of it. It gets way too hot out here in the shop to not have air conditioning. It is a split hip heat pump. So to compensate for the air conditioning not working, I got a fan running, and it's early in the morning, so it's not gotten hot yet, but it's going to get hot. That's why I want to come on out here this morning and see what I could get done. I might have to spend all afternoon working on the air conditioning. I am not an air conditioning man. Every time I work on one, I always go on Google and Google what it does, and most of the time you never really find an answer on Google. comes to air conditioning. So many people are so, I don't want to say this, biased about it. I used to have several friends that was in the air conditioning business and into radios. And it was a bit of a trade-off. I work on your radio, you come fix my air conditioning. And those guys do not play with radio no more. So that kind of shows you what the friendship led to. Alright. Well, after 2 failed days of trying to work in the shop, we are back in here. And the reason being was that Monday the air conditioning out here in the shop started acting up, and then yesterday it completely failed, and temperature was like 98 degrees outside. It got up to about 88 here in the shop. Anyway, like I said before, I'm no air conditioning man, but the unit act like it was going into defrost mode, and the cooling fan outside would shut down, and you could hear a buzzing and a lot of heat coming up from the outside unit. Well, after doing some testing, I found out that the fan motor had went bad. So got it replaced yesterday, and it's a nice cool 74 degrees here in the shop, so we can get back to work on the ICOM 746. So we're trying to figure out what's going on here with R44. That is running extremely hot. I mean, this is so hot you cannot even touch it. So I went ahead, and the service manual, the schematics are usually broken down in 3 pages, and that's very hard to troubleshoot through it, you know, on the computer screen. So what I done was printed out the 3 pages and went ahead and taped them together, cut off the edges, you know, just taped them all together. And we can see R44 right here. Now this is the 14 volt source that comes out, goes out the radio and goes to many different places. When I use R44 as like a drop-in resistor here, and then it goes down to the input of IC2, which is a 5 volt regulator. Now when I check the output of this 5 volt regulator, it should be 5 volts, but it's actually in the millivolt range. So first thing come to mind, you know, was this regulator was shorted. So I have the ribbon cable removed so you can see the regulator here. This is the IC2, the 5 volt regulator, and then we have an 8 volt regulator beside it. This radio has a lot of different regulators in it. When you plug the cable in, you get a direct short on the output of IC2. With the cable unplugged, that short goes away. So this means that we need to follow this cable around to the other side and see where this trace is going to and where it splits off at. So I've reattached the cable on the other side and turned the radio over, and this is that cable that is connected to the output of IC2. So we need to find the pin here, and we'll look through and see where this 5 volt is going to, and hopefully we can locate the shorted component. So laying here on the bench is the main schematic all put together, and up here on the top left corner, this is where that 5 volt comes into. It's actually pin 25, and it comes into the circuit. And as you can see from the yellow highlight, it goes out many different points here, and it runs all the way across the whole length of the schematic in several places, and just jumps off everywhere, and then it even goes out the other side here. And probably the best way to do it is that we'll find pin 25 here on the schematic, and should be a test point CP 1330, so we can get our own reading from here to ground. And what we'll start doing is pulling different ribbon cables up and see if that short goes away, and that'll tell us if it's in another board or if it's on this main board here on the radio. So we're looking here at this board layout, and we can see this connector, and this is the connector that goes around and attaches directly to IC2, that 5 volt regulator. So looking here from pin 30 come down, we see P5V on both sides of the rail, so that's pin 24 and pin 25. So all we need to do is come here and count 4 pins down. That'll be pin 24, and that's pin 25. So we can locate them on the board. There should be a pad here somewhere, and I think that's it right there beside this inductor. But we can probe directly on that pin for our short, and then we'll start removing other ribbon cables and see if that short goes away. Once we get all those ribbon cables removed and we still have a short, we know that our problem still lies on this main board. Now you remember Q1705 that we replaced is right here. So it kind of tells me that the problem is on the main board, but we need to verify just to make sure. These signal paths runs everywhere on this radio, and one of the 5 volts rails just come through and just goes right through the board and not even connected to anything, and then off the other side to another board. So it's kind of hard to tell, so we need to use process of elimination here. So our connector, which is 1331, I do believe it was, is right here. And if we count 4 pins down, it's 1, 2, 3, 4. We can see that this trace goes to this end of this inductor here. So we can use that as our point. There's a pad there, and it does not appear to be attached to pins 24 and 25. So we're looking here at the voltmeter, and we see we have about 1.2 ohms. So what I'm going to do, I'm going to start removing these ribbon cables. There's actually 4 more. There's 2 here, and there's 2 over here. So we'll start removing these ribbon cables and watch our voltmeter and see if that short goes away. Right now it's leveling off at about 0.9 ohms. It went down about 0.9. You got to be very careful removing these cables. And as you can see, when I removed this one, we went up to about 236 ohms. And that's when I pulled this one out. So we'll go ahead and pull the other two out and see what happens. Still at about 236 ohms. And for the last one, about 245 ohms. So I reinserted these two because they're not making any difference at all. But as you can see, these two do make a little difference. When we plug the end one back in, it'll drop down to about 66 ohms. Okay, in conclusion of testing here, it looks like everything on this board is okay as far as the 5-volt rail. And when we check this connection here, we're up to about 151 ohms now, so that should be enough for a turn on. And that's with this one ribbon cable here disconnected. Now with this plugged in and everything else disconnected, we're down in the 0.9 or so ohms. So it looks like our problem lies somewhere where this ribbon cable here is going to, and it says to control unit. But what I want to do is check our 5-volt rail with this disconnected. Now this one will have to be connected because it goes to the front panel, and you cannot power up the radio without putting a pull-up resistor here going to ground. So we don't want to really have to do that, so we'll just leave the control cable disconnected, and we'll power up and check our 5-volt rail. Okay, we got our probe on the 5-volt rail. We have the ribbon cable going to the control board disconnected, and we'll reach down and hit the power button. And the first thing you see is that we have display. And it would work better if I had the voltmeter in volts instead of ohms. I like this voltmeter, but it's not auto ranging, so you got to well, it is to a sense, but it doesn't auto on AC DC like my other meter does. And we're at 4.92 volts, so our 5-volt rail is back alive. So now we need to go over here and troubleshoot this control cable, and what we need to do is look at the schematic and see where our 5-volt is running over at in the control cable. So back at our schematic again, our 5 volts coming from the of the unit, and it snakes around and comes out here on J1332 to control unit. Right here. So we need to find the control unit schematic and have a look at it. Alright, looking at the block diagram, we can see J1332 here, and we come down, we see our 5 volts right here. It's C5V, and there's 2 lines, and it runs straight into the control unit. So let's see if we can find this control unit schematic, and we can see that the speaker connects to it down here near the bottom, so that will be easy to find on the radio. There's our speaker connection here, and it has multiple cables running off to the tuner, and also our antenna connections up here at the top. So that should be fairly simple to find in the radio, but let's look for the schematic. Again, you know, this is what I was talking about. Looking through these schematics, you can see it's just pages and pages of partial. You know, this is the main unit. Then you go to another schematic, and you have to go all the way through it to find exactly what it is. And I did not see a this one is not labeled, but there's too much here going on to be just a control unit. You have the chassis, PA unit, filter unit. See, all that's tied into one control unit. Here we are. So there's 1 page, 2 page, there's 3 pages of the control unit. So all I'm going to do, I'm going to go ahead and print this out so we can troubleshoot through it. Come on, you can do it. Okay, and we want to do, I've got so much opened up on this computer right now, it's crazy. We want to do current page, that's page 124. Okay, sorry about that telephone. Okay, so this is page 124, so we need all 3, so it'll be pages 124 through 126. It's just a lot easier for me to look at all of it at one time instead of sitting here and tracing through each page on the computer. So I went ahead and printed out the control unit schematic, and me and Mike was just talking about this the other day. Some of these schematics, when you download them and go to print them out and line them up, they will not line. It's because of the way the folks scan them, and this one here was actually scanned without any problems, and everything matches and lines up. So this is our connector here that goes to main unit J1332, and this is where the 5 volts come in. However, ICOM has thrown us for a loop. You can see the 2 C5V connections here, and what do you don't see? They come in and they stop and they do not go anywhere. So yeah, they're trying to be funny on us, so we're going to have to go to the control unit and find these 2 pins and see what they're connected to on the board, and possibly the board layout, if it's readable enough, will show us what's going on. And we can see the layout here of our control unit, and this is J7, and it says to main unit J1332, so this is the connector we're looking for. And looks like pins CV5, it's going to be pins 16 and 15. And if we look at our board layout, it's 5 pins down. We can see that they are connected here on the board layout. Now I need to figure out just which component they're connected to. Okay, and as you can see, this is looks like an inductor here, but it's L3 maybe, it's hard to say. That's L29. Can't make out these, but it's not two numbers. So we're gonna have to look at the actual board and see if we can see just where this is connected to, and see if we locate it on the board, and hopefully there's some silk screening here that'll give us something. And we can see the trace is running off this way. Looks like it goes on down here to L5 maybe. Okay, label was at the door. Anyway, looks like it's going down here to L5 maybe. And then there's a capacitor here that we cannot read. Anyway, we're going to have to go to the board and see if we can find all this. At least we do have a designator here, L5, and then go back and look at the schematic and find that and verify that that is the 5-volt rail. Again, you know, without getting the original service documents on this stuff, sometimes you know, it's a guessing game. Okay, so I started, you know, the troubleshooting process on the control board, and as you can see, it's mounted right over top of the tuner, and this is our ribbon cable that comes in. You can see right here, that's our 5-volt line, and it comes into where this inductor is supposed to be, and that inductor is not populated on this board. So, you know, when I checked it, it still showed a short to ground. I started looking at the ribbon cable, and the ribbon cable don't look like it was plugged in right. It was kind of sitting at an angle. So I unplugged it and plugged it back in and checked on that 5-volt line, and the short was gone. And I said, possibly, you know, that couldn't be the problem. But sure enough, I had the radio in the on position, and I'll come down here to R44. You know, I can touch it, I can hold my finger on it. It's a little warm, but you know, that's expected when you're dropping from 14 volts to 8 volts. It kind of acts like a current limiting resistor here. So, you know, it's going to get a little warm. But I just thought this was interesting, that perhaps, you know, it's just hard to say, because that's all I've done was remove this ribbon cable and plugged it back in, and the short went away. Now perhaps that was a piece of you know, a solder ball or something had got trapped in there, or you know, a little piece of foreign metal object or something, or maybe, you know, it just wasn't plugged in correctly, and that was causing the problem. But turn the radio around, you see that our display is all lit up, and it looks like everything is working. Very interesting. And we are powering the radio from our Harrison Laboratories power supply, and we're at about 13.8 volts. Again, we're at 13.8 volts, and we were drawing just about 1.5 amps in receive mode, when before it was drawing just a shade over 2 amps. So yeah, it's an interesting problem. I'm gonna have to run the radio and look at it and see if we can find anything else. You know, it's just interesting that now everything is back working. Yeah, we fixed some problems. We did a little bit of troubleshooting. And sometimes, I don't know why, radios hit my bench and fix themselves. It's happened more times than one, but interesting. Okay, I have the radio hooked up on the standard bench supply. So we have plenty of amperage on the radio now, and we turn the volume up. And you see we have volume. Oh my God. It's a whole fleet of alien ice cream trucks. It's a long story behind that. Dino and Michael know exactly what I'm talking about. But that's actually J65 mode that we were hearing then. But yeah, like I said, Dino and Michael knew exactly what that meant by the ice cream trucks.
I'm going to read the logic for you.
Well, I went through the radio, checked everything out, and could not find any other issues. Transmit's fine. Everything seems to be working like it should be. And probably the only thing now is to go ahead and make sure all the screws are put back in it. Still a couple of harnesses got to be bolted down here and there that I haven't done yet, because we didn't know how far we're going to have to tear back down into it. There's a missing screw on the speaker. There's supposed to be 2 washers under it, and I'm going to have to find 2 of those and put under it. But the radio seems to be back alive, and it's just really amazing to me that, you know, the ribbon cable was causing the problem with R44 getting so hot and knocking the 5-volt rail down. That was very interesting to find. But anyway, another radio back up and going, and let's go ahead and get it all back together, and then after it's back together we'll test everything again and make sure it's still working. So everything checks out real good now, so the only thing left to do is that we need to mix up a little CW2500 conformal coating and touch up our traces down here around Q1705. And as we know, you know, a SOT 416 package is very, very difficult to work with. They are so tiny. And I mean, even in the camera lens you can barely see the component down there. I have it mixed up. There's a lot of waste in this stuff because it's only going to take just a couple of drops. This will get everything glued back down in place, and will not be no exposed circuit traces. And as you can see, after doing that, you know, it's just 2 little drops, and you know, so a lot of it goes to waste. And this stuff is about $25 for the tube, so every time you use it you do waste a lot.
That's why I'm saying, if I knew what I knew today, I would have got a hazer. You know,
Okay, well, the radio is all completed. Everything's back together. Checks out real good. No problems. Should be another happy owner. But the big thing is, buddy, we saw you replace a transistor. We saw you do some voltage checks. And we come up with a conclusion that a ribbon cable caused the initial problem. But what caused the main failure? What caused the transistor Q1705 to explode? Well, my assumption is that the way these radios designed with its multiple power supplies and voltage sources is that they're in what's called a cascade. And you have your 14 volts going into a 8 volts regulator, and then that's dropped down to a 5 volt regulator. Well, the 8 volt regulator is connected to one side of Q1705 through various sources. And what I think is that since the 5 volt is connected directly to the 8 volt, when the initial problem happened, and that shorted the 5 volt rail to ground, you notice we had that dropping resistor in there, R44, that caused a voltage spike to go through on the 8 volt source, and in turn took Q1705 out. The voltage might have spiked up or something, but anyway, that's probably what blowed Q1705. So, you know, it's fairly simple to really see what happened. It just looks very complicated looking through all those schematics, but in theory, you know, it's nothing out of this world to think about. But anyway, John, there you go. The radio's all ready to go. Back together. We'll get it boxed up and get it back to you. And hope y'all guys enjoyed the video. So in conclusion, I think the problem with this radio was quite obvious. When we went into the radio, you know, we noticed some screws were missing. We also, if you go back and look in the video, you might would have seen someone had marked and wrote comments in a black marker. One of them was saying, in fact, on the control board itself, it said no good. And also on one of the covers it said no problems found, this and that. So the radio has obviously been worked on before, and it's probably way back before John got a hold of it. So I would say that the main fault of this radio was a self-inflicted from you know, a misguided repair somewhere back in time, that someone had it and went through it and probably didn't you know, clean up behind itself, got some debris in there, and didn't plug cables back in like they should be. So, you know, that's just my thought on it. I thought this was pretty interesting. I wanted to add to this video. I'm looking at receiver sensitivity. As you can see, and on AM it says 10 dB cyanide, and it's 13 microvolts at 0.5 to 1.799 megahertz. Let's have a look at that and just see how close this this receiver is. You see we have our radio dialed in at 1.799 megahertz. And okay, I have the Rigol dialed in at 1.799 megahertz. Have a level of 13.0 microvolts, 1 kilohertz tone. We have our Sinidal 3 hooked up, and looking at the level, that's a little bit over 15 microvolts. 15 dB of cyanide. And just so you can hear, that's receiving it through the cyanide bed in the speaker. So it looks like the receive sensitivity is real good on this radio. I just thought that was kind of interesting and wanted to show that also. Very hot receiver. Well, that pretty much wraps it up on this repair. Again, you know, it wasn't too complicated. The problems just seemed to went away in the end, which is always a good thing. So, you know, if you like the video, you know, let me know by leaving your comments down below. And if you like, hit the like button. That does help. And if you haven't subscribed, please do so. We still have the 5,000 subscriber giveaway going to be coming up here shortly. I noticed the counter is still going up pretty nicely. So we'll be getting that video here out in the next week or so. Hopefully, if everything goes right. Anyway, you know, click the show more tab down below. And follow the links there. You link to our Patreon if you'd like to support us. And we'll catch you in the next video. See you now.